Hey guys, it's me again, and yes, don't worry, I'm not dead because I'm right here. It's just I'm a little more busy nowadays. So, yeah, I haven't made any videos for a really long time, so I was thinking of making one right now because all of you are just so interested in physics, so yeah. But really, I think a lot of people might be struggling in statics, particularly because it really is a difficult course, and it's only recently that I've just had that epiphany moment where I just finally understood what I was doing. So I'm sure a lot of people are still struggling like I was just a few days ago. So just to see how this goes out, see if this helps anyone, I guess I'm making just a physics show video just for one of the questions for homework. And because this is a Wiley Plus question, this shouldn't be considered cheating because a, a different, everyone gets the same question but with different um, magnitudes for each force in the question. So yeah, you'll understand. So my version of the force is what I'm going to solve tonight, and our $1,000,000 question is this. Question 2/163. Now the question is, replace the three forces acting in the structured support with a wrench. Specify the coordinates of point P in the xy plane through which the line of action in the wrench passes. The 15 kip force is at the midpoint of line AB. So basically what it's saying is that there's a wrench force that's passing through the xy plane, so the z plane is equal to 0. So it's somewhere over here. Yeah, and this is point P, and the x, so to find the coordinates of the xy plane, so we're going to say that x is right here, and this is going to be y. Now, yep. And since D is at the midpoint, that means that D is 5 inches up, and it's it's 6 inches up, and it's 5 inch. Oh, goddamn. Alright. Okay, I said my first swear word, so I guess this won't be shown in classes, so... Oh, god damn it. Seriously, I forgot. I left my eraser at home back in back in Surrey. Oh god, I can't go back there anymore now. So this is 5 inches since this is the midpoint. And this is 6 inches. Now, some professors are really picky, so for the neatness of how you write this in the format, so yeah, be sure to write it down correctly if this is an assignment question. And well, I guess it's just good to practice how to write work professionally, or at least make it look professional, because if you get the wrong answer, I guess it's not really professional. And you don't want a bridge that you built to fall down because of some faulty error. Now, what we want to do first is find R, and that's the resultant force. So R equals the sum of all forces. So we can see that there is an 11 kip force, and just to let you know right now, for those who don't know, who didn't attend the tutorial, 1 kip is equal to 1,000 pound forces. So yeah, it's probably because the imperial system is just stupid, and for some reason America is still using it. And since Trump is the president, I don't predict that they're going to change that anytime soon. So yeah, they're the only people that are still using the imperial system. Probably some other countries out there, but the most significant country is America. That's why it's awesome to live in a place that uses SI units. Outside right now is 6 degrees Celsius, not, I don't know, 90, what is it? 41.6 degrees, no, like 45, somewhere around there, 45 degrees Fahrenheit. No, it's, okay, now back to the topic. Now we want to find R, so R is equal to, as we see, there's a 15 kip force that's along the x-axis in the positive direction, so that's 15I. In the y direction, there's a 28 kip force in the positive side, so plus 28J, and there's a negative 11 kip force in the x direction, in the z direction, so that would be minus 11K. Okay, now we want to, you probably, for this question, you want to find the unit vector of the resultant force, because this is a wrench, and you're eventually going to have to convert the moment about O to the axis on which the resultant force is. And yeah, I'll talk a little later about converting the moments, because basically what a wrench is that it's a force-moment couple where the moment is parallel to the force, and you to make the moment parallel with the force, you convert it to that axis that the force is on. So yeah, now so that's R. So now we want to find N, and this shouldn't be too hard. So N is equal to 15I plus 28J minus 11K, and if you don't know how to do this by now, you're probably in big trouble now. Over, okay, 15 square plus 28 square plus 11 square. Now I'm going to use my calculator off screen. Okay, I'll show you the shadow, so I'll prove to you that I'm using a calculator. Now first going to figure out 15 squared plus 28 squared plus 11 squared. And 15 divided by that's 0.44. Okay. N is equal to 0.4462. Okay, I'm going to round to 4 decimal places in this video, although I usually do 3, but just for precision, I'll just do 4. Plus 0, oh, forgot the unit vector, I, don't forget those, plus 0.8329, J minus, I know it's negative, 0.3272 K. Alright, now we have the resultant force and its unit vector. Now we're going to find the moment about point O, and that's, conveniently enough, it's in the origin. So let's see, we have, so MO just want to partition these just to be a little more organized. So MO, well, we have a 15 kip force. Okay, let's calculate the things about the x-axis first. Now we have a 28 kip force that's 12 inches up on the z-axis. Now that's, since it's on the y, since the force line of action is parallel to the y-axis, it's not going to create any moment about the z-axis, but it will produce a moment about the x-axis. Now using the right hand rule, my fingers is pointing this way, and you can see that it's counterclockwise, so that's going to produce a negative moment about x. So that's equal to 12. Alright. Now we're first going to do that. It's equal to 28 kips times 12 inches in the x direction in unit vector I. Now that's the only thing for the 28 kip force. We have an 11 kip force right here, but since it passes through the origin, it's not going to produce any moment at all. So that doesn't affect anything. Now we have the 15 kip force. Now that's going to produce a moment about the y-axis and about the z-axis. Now let's first, just to get things in order, we're going to calculate what its moment about the y-axis is. So using the right hand rule, it's a positive moment would be counterclockwise in this case. You see that it's counterclockwise about the y-axis, so it's going to produce a positive moment. So I'll put a plus right there, and since this is midpoint on a 12-inch tall pole, there's no Pythagorean, there's no trigonometry that you have to do with this. You know this is halfway, so that's going to be 6 inches. So that's going to be 15 kips times 6 inches in the j direction. Okay, plus, now this also produces a moment about the z-axis. Now using the right hand rule, you see that this is going clockwise about the z-axis, so it's going to produce a negative moment. So this is actually going to be minus 15 kips times 5 inches in the k direction. Now, as you see, I'm using the sort of asterisk type of multiplication sign because in statics you're often going to cross multiply things, and I just want to reduce ambiguity, so this is an asterisk. Now if you simplify that, which you definitely should, 28, oh, here's the calculator, 28 times 12, that's 336, equals 336i plus, I don't need a calculator for this, 90j minus 75k kips times inches. So that's the moment about O. Now we have what we need. So since this is a wrench force that we're calculating that's passing through a point on the xy plane, we need to know what the wrench is. Now let's define that the moment about the O is equal to the wrench moment plus r, the position vector, times the resultant force, cross multiplied the resultant force. Now the wrench moment, now as you see, we're just going to draw a little diagram right here. This is This is Z, this is Y, and this is X. As you see, we're getting some sort of resultant force that's kind of going to look like this. Yeah, it's going down, it's going in the X direction, and it's going in the Y direction. Now, and this is going to produce a moment that's going kinda in... Wait, did I do this right? Yeah, I did it right. Okay, it's going to produce a moment that's kinda, I think it looks like this, and you basically convert part of this moment into this moment right here. So the rest of the moment that isn't about the r-axis, so it's going to be like this component and this component, all the perpendicular components to this axis, that's going to be what this is. So what r is, the position vector, that is from O to here, because in this line of force, we know that this line of force is intersecting the xy plane at point P, and we define point P as x and y. That's what the question is asking for. So r, so we're going to say r is equal to xi plus y j plus 0k, because it's on the xy plane. There's no z involved, and if there were, that would be an even more cruel and unusual question, and unfortunately in the midterm it said that there will be a question like that, so, well, all I can say is just good luck with that, because the average grade in the midterm last year, from what I've heard, was 33%, and so yeah, this is definitely a very challenging course. By now I'm not that afraid of failing, but I'm still afraid I'm not going to get a very high mark in this. But let's just do our best, hope for the best. Now r is equal to this. Now, we already know what the resultant is. Now the wrench, as I said, it's the parallel moment to r, so that's going to be the moment about point O, the dot product of the moment about O times the unit vector n times the unit vector n. Okay, so this would get the magnitude of the wrench, this would get the vector of the wrench. Okay, now we're going to find the wrench first. Now, W is equal to MO dot n times n, which is equal to 336 times n is 0.4462 plus 90 times 0.8329 plus, or wait, actually, yeah, improperly this would be, oh well, plus negative 75 times negative 0.3272, all multiplied by the unit vector n again, so that's going to be 0.4462I plus 0.8329 J minus 0.3272K. And using a calculator, 336 times 0.4462 plus 90 times 0.8329 plus 75 times 0.3272, because it's negative times negative, that cancels out, makes it positive. And multiply that scalar value by each of the components. So that's for my case, that's 249.4242. So alpha A, let's see, that times 0.4462 times that equals 111.2931. Again, rounding to 4 decimal places. Multiply that by the 0.8329, that's 207.7454 J minus 0.3272, 81.6116 K. Now I'm just going to look at the back. Did I get it right? Wait, 336. Oh shoot. Okay. Alright, this is a negative moment about x. Sorry. Negative 336. Alright. Crap. Okay. Okay, fuck this. Alright. Now, what did I do wrong here? I got the unit vector right. 12 times 28, negative 336 plus 90 minus 75. Okay, got that right. 0.336. Okay, this is negative 336. I'm so sorry about that, guys. I'll probably include a disclaimer if I bother to edit this. Okay, now, oh yeah, that should definitely affect the dot product now. Let's try negative 336. Negative 336 times 0.4462 plus 90 times 0.8329. Alright, don't look at that anymore. Don't look at it. Alright. Just going to erase this part. Because, okay, we didn't screw up that badly. Or, well, I didn't screw up that badly. Yeah. Crud, this is bad for production, boys. Well, plus 90 plus 75 times 0.3272. Okay, so that gets negative 50.42 222. That's the scalar value, and really that would be positive because, like, okay, never mind. Ignore what I said. Sometimes you have to make it positive for in some situations, but don't take that because that's not in the question. Now, multiply this by 0.4462. Okay, alright, we're back on track. So that would be negative 22.4984 in the I component, plus, oh wait, actually it's probably going to be negative 0.8329. Oh yeah, I was so correct. Alright, we're getting there. Negative minus 41.99. Goddamn these pencils, they're not made in Japan. 67. J, come on. Minus. Okay, negative 0.3272 times that, so that would be, oh, actually plus 16.4981 K. Okay, that's your wrench moment. Now we're going to have to find our cross product resultant force. Now that's going to be equal to, what was it, 16, oh my, this is 27 minutes long right now. Oh wow, this is a lot longer than I was anticipating this. I've done this question before, but it definitely took longer than that, but still, this is a tough question. Well, probably because of all this commentary, I'm taking time. Now, R cross product R, that's basically, I don't understand why they didn't explicitly say that in the lectures or tutorial. Well, okay, they did in the tutorials, but they never said it in the lectures. At least my professor didn't say that. It's basically the determinant. So in the I vector, J vector, and K vector. Okay, you know what? I'm just going to widen this because I know later on if I don't, it's going to fuck me in the mouth. So there we go. The R vector, that's X, Y, and 0. Remember, it's on the X plane. And if you look, you know, you can rewind. I'm not going to do this anymore. Enough of that shit. Now, R is 15 and 28, negative 11. Okay, pretty simple, right? Which is equal to, now, if you do cofactor expansion on this, if you find the cofactors on the first row, it would be I times Y times negative 11 minus 0 times 28. That's basically negative 11 Y I plus, or let's, no, this is in the J, negative 11x, okay, minus negative 11x, J, because remember, plus minus plus, there's that checkerboard pattern to find the cofactors. No. And K, so that would be 28x minus 15y. Okay, there we go. Equals the negative 11y, the I component plus 11x in the j component plus 28x minus 15y in the k component. And technically that would be kips inches. Now, okay, now we got that. Finally, we have enough information to solve for x and y. Remember, oh, it's wrong paper, that's my script for the video. Oh, wait, no, that's the script. Okay, alright. Now, remember, the moment about point O is equal to the wrench moment plus R cross the resultant. R, that being where it couldn't be any position vector from point O to the line of action, and since we know the line of action intersects on the xy plane right here, we define that as that, and that's what the question's asking for. That's how we get R. Now, since now we know that the moment, finally, the moment we've all been waiting for. Oh my, I'm patenting that, yeah. Alright, moment about point O, remember that's a vector, equals the wrench plus R cross resultant. Now, what the moment is negative 336i plus 90j minus 75k. I'm not going to write the units because I just want to finish this already. Equals to the wrench, which is negative 22.4984i minus 41.9967j. Okay, let's just check my leak sheet. Am I doing it? Yeah, I'm doing it right. Okay, plus 16.4981k, and there's also that R cross resultant, so that would be plus negative 11y I plus 11x j plus 28x minus 15y k. Now this is just not a very big system of equations. It's pretty easy to solve. Now let's just see. To write this in a more readable form, you can say that negative 336 is equal to, and all the components in the I, that's negative 22.4984 minus 11y. So let's just say that's negative 22.4984 minus 11y. Okay, that's not too hard. You can just solve for y in this case, and 90 is equal to, now let's see what's in the j component, negative 41.9967j. Fuck, I mean, yeah, fuck. Okay, equals negative 41.9967. Okay, plus 11x. Okay, really. Wait, 11x. Did I write this down correctly? Okay, negative 11. Okay, yeah, I did it right. Okay, alright, all good. I'm okay. Let's just see. Okay, 11x, and negative 75, that's equal, oh, I have to move this up. Negative 75 is equal to 16.4981 plus 28x minus 15y. Now we have just two variables, so we can tell this equation in the system to go fuck its face. Now we're going to rearrange this to say that, okay, you know what, I'm sure you all know basic arithmetic, so we'll just solve for y. Negative 336 plus 22.4984 is equal to, divide that by negative 11 is equal to 28 point, alright, so we got y is equal to 28.5001, and you know, I think the actual answer is 28.5, and we just get this little decimal from the small round estimation errors, and that's one thing. You want to keep as many decimal places as possible. This isn't like chemistry where it's stupid with significant figures. This is physics. We aren't fucking around in physics. This is it makes a lot more sense, actually. Now solving for x, yeah, you don't want to solve for two variables. Fuck off, now. Get out of here. Okay, now 90 plus 41.9967 equals, divide that by 11.9997. 9997. Now, that's it. I'm guessing the original answer is 12, but that's basically it. There you go. Ta-da! I did it. Aren't I a genius? No. I can't imagine making a video for every single question. This is going to take ages. That's why tutorials are paced much faster, because they can't sit around doing this shit for 37 minutes. No. Okay. Anyway, yeah, there was just one small fuck up with the negative moment about the x-axis, but yeah, you see this is going okay, get out. Okay, this is going clockwise, so yeah, according to right-hand rule, that's negative. For some reason, I was jerking off and just wrote 336 when it's obviously negative 336, and this is negative 28 kids. So there we go. Okay, but we got the right answer. Hopefully this helps some understand this, and hopefully I didn't put you to sleep. If you want to sleep, you could just don't take drugs, or take drugs. Sleeping pills, sleeping medications, I don't believe in that crap. Okay, sorry for being a little disrespectful. Maybe some people actually do take sleeping medications. I'm just insulting them. I'm sorry. I'm so sorry. Don't crucify me, please. I'll dress up as Santa this Halloween and I'll pay back whatever insult I made. Now, anyway, yeah, it's almost 1 o'clock, so hopefully this helps. See you later, alligator. I'll be back. Yeah, bye.